Good day, everyone. Today we are going to do our class 2 online, physical science, geometrical optics. So we are going to focus under the topic which is reflection, as you can see here. So this is geometrical optics under reflection, grade 11. So lesson by myself and I. So now we're going to talk about or focus more about reflection. So first, what is optics? So optics, we say that optics is the study of how light travel, and then we also have what is known as a light ray. So we need to focus on what is a light rays. So we cannot talk about a reflection without talking about a light rays. So these are the lines that shows the light. So before we go deep into what is a light ray, imagine the light when you're standing in front of the car. So if the car is coming towards you and you're facing the light, so what normally happens is that, so the rays are going to strike your eyes, and by that we call it reflection. So the light is going to be reflected to your eyes, and then at the same time you're going to detect or notice that there's a object coming. So what is a light ray? A light ray, we say these are lines that are perpendicular to a light wavefront. So in geometrical optics, we represent light rays with arrow with a straight line. So this is the arrow and straight line, so which we use to represent a light ray. So at the same time, remember the main focus here, we want to talk about a light rays. Are the light rays real or not real? So the light rays, they are not real. However, they are merely used to show a path that the light travels. For example, let us look at the light rays showing the light wavefront. So this is the bulb here showing a light wavefront and a light rays. So this is the bulb here in this point. So a bulb at this point, and then you do have here, this is a concentric circle, so which is known as a wave front. So at the same time, you look here, remember previously we talk of what is called a light rays. We say light rays are lines which are perpendicular to the light wavefront. So you need to have a light wavefront in order for you to have a light rays. So let us check. So wavefronts, so light wavefront, this is the 1, 2, 3. So these 3 circles, they are representing light wavefront. So they say that the light rays, they are lines that are perpendicular to the light wavefront. So this line here is perpendicular here at this point, and at this point, and at this point is perpendicular to the wavefront. Now from there, we say in this case, remember what is this? So this is a light bulb. So light bulb is a source of light which produces a light wavefront and a light rays. Now, why do we see objects? Every day we notice things. Even this presentation which I'm making, you can see it because of what is known as light. Let's say the screen was black or blank. What were you going to see? Now, why do we see objects or things? Now, let's consider figure 5.1 below, which is this one here. So, you see here, this is the trolley, and you observer here. Right. When you're standing at this point, your eye will be able to see the corner here, and another corner, and one wheel. However, the other one will be hidden. So, we can only see an object when a light from an object enters our eyes. So, if the light from the object does not enter our eyes, then we cannot see this object here, or whatsoever object it may be. So, when the light travels from an object to the eye can see the object. That's what I just explained. Light rays entering the eyes from the cat are shown by the dashed lines. So these dashes here, 1, 2, 3, and so on. You have this line of dash, and this line of dash, and this one, and this one. So they are representing a light rays. Remember, we say that we represent a light. We represent a light rays with arrow and straight line. There must be arrow and a straight line for showing the direction. Where is the light coming from, and where is it going? Right. Then let's proceed. Now let us look at this object. You can consider a scenario or a case whereby you are having a candle, and then you take a piece of paper. So let's say you take the first one here. This is the first one, and then you'll observe. So let's say you just do like this. You take one piece of paper, and then you make a small hole, and then you observe through the hole. The light, make sure that the candle is on. Make sure that the candle is lighting, and then from there you stand at a distance and observe through the hole whether you'll be able to see the light or not. So if you look at the dash here, those two dashes which you just see on the other side of my hand, on the right of my hand, they are showing the path of the light. Now, you take another piece of paper, the second one. Again, the light will pass through the hole of the first paper, then to the second, and then on the other side of the second, you will be able to see the light. So a light will enter through the point A and then to point B, or media A to media B. And then you will be able to see the reflection, which is the light coming through your eyes. Now you take another paper. So the same behavior or the pattern. However, the amount of the light which you are going to see is not going to be the same. When it's one, you're going to see more rays or more light ray. When there are two, the light is going to be reduced. When there are three, again, more of light is going to be reduced. Right. Now, let us go to the next slide. How can we draw a ray or ray diagram for reflection? Remember, reflection is just like you stand on the mirror and then you see yourself. When you see yourself, that is actually a reflection, a bouncing. Okay, how can we draw rays? Right, we want to draw ray diagram for reflection. How do we do that? So we say first we need to know what is a ray diagram. So looking here at this, right, a ray diagram is a drawing that shows the path of the light rays. So you need to know that there must be a path first. There must be a path of showing a light rays. What is a light rays? Remember, we are talking from the beginning, a light rays. That is the first focus before we talk of what is exactly a reflection. Right. Light rays are drawn using straight lines and arrowhead. So that is what we said, that in geometrical optics, we represent a light rays with straight lines and arrowheads. We say the figure below shows example of a ray diagram. Now, remember, you are looking at your friend or a little baby or a baby. Then if you look at this point here, you do have an object which is a person. Then you'll be able to see the feet and the hand, neck, and the head. So that is because of the light. The first light which comes here is from the sun, right? Or you find that the room is having a light coming from all the direction. However, for you to be able to detect or to see that person, there must be the light ray from that person. Now, let us look at the case whereby you are having a mirror. So this is the mirror here. A mirror is here, and then you do have a candle, and then this is you here. So if you put a candle here, so the light will go to the mirror, and then when you are standing on the other side, this light will be reflected to the other side. You can also make this by switching off the lights during the night, and then you switch on the candle, and then you put a mirror at a distance, right? Even though the candle is not having that amount of light. So this reflection mirror here, or a mirror, is going to reflect the light to the other direction, such that the whole house is going to end up having more light than the actual candle can produce. Why? The light rays travel towards the mirror, and the mirror then reflect to the eyes for detection. Right. Then remember, the mirror here is acting as a reflecting surface. Now, let us look at the properties of light. What are the properties of light? What are properties of light? First, light can either be reflected, absorbed, or transmitted. Right. That's why we look at the previous, when you look at the previous object here, the light is being transmitted to this point, to this point. And at the same time, this light is going to be reflected. I mean, that is it transmitted to the mirror and then to the person. Then, same time, we say that it's reflected. However, not all amount of light is going to be reflected. Some of them, if you look very well, some of them, you may find that if you touch the mirror, you find that the mirror is now hot. If, let's say, that amount of that light was too much. So, the reason why it will be hot is because, now, okay, if you look very well here, this point here, some of the light is going to be converted into heat energy. And during the process from this point to the other point, some of the light is going to be converted to the heat energy. That's why we say that light is a source of energy. Right. Let's proceed. So we say that when a light interacts with an object or a medium, such as glass or water or a wall or any other things, we say that the light can either be reflected or absorbed or transmitted. So these three are the properties of light. Now, let's consider reflection now. That's where our focus is going to be. First, okay, let us consider reflection. We say reflection occurs when an incoming light bounces off from the surface. So, if you look on this line here, reflection occurs when an incoming light ray bounces off a surface. To describe the reflection of the light, there's something which you need to understand. Those are terminology. We have the term normal line. Before normal line, we have something called incident ray. Then we have incident ray, normal, and then the angle of incident. And then we also have reflected ray and angle of reflection. So now, what is an incoming light ray? So an incident ray is the incoming light ray. So this light, you find that is coming from a certain source. For example, you find that you're having a bulb here. So the bulb is a source, right? So when it comes to an incident, the light that comes from the light source is called incident ray. So that's why they say incoming light rays is an incident ray. Then we say again, we say the light ray move away from the surface. The light rays moving away from the surface is called the reflected. So these incident rays, they move from one point like this, and then let's say this is a surface, it strike the surface at a normal. Here you find that you're having a normal line to the surface, and then it's reflected. So which means that bouncing off at a certain angle. Right. So this line here is going to be reflected line, which is a reflected ray. So reflected ray is a light ray moving away from the surface. And then the most important things about the ray is that their angle in relation to the reflecting surface. So what is this reflecting surface? So this reflecting surface is just like a mirror. It can be a wall, it can be anything that can make the light reflect, including you. It can be a reflecting surface. So these angles which we're talking about, they are measured with aspects of normal surface. So normal is a imaginary line perpendicular. Normal is a perpendicular. Normal is it's an imaginary line perpendicular to the surface. And then we also do have what is known as the incident. Here we do have what is known as an incident angle, or the angle of incidence. So this is measured between incident ray and surface normal. And then we also have the angle of reflection. Angle theta r is measured between reflecting ray, right, and the normal. Now, what is really reflection? So imagine during the time whereby you're having a lightning, and you're inside the house, you just see the light inside the house. Then there's no electricity, you just see a person standing there, or a refrigerator, and then you just get scared because you never expect such. So the light which you see and things which you see in the house, you find that the light shines outside. However, it is able to penetrate and being reflected inside. So a lightning is the best example of how reflection occurs during the time whereby there's a load shedding. And then we also have the light from the sun and the moon. So these three are the major things that gives us reflection. Now let us look at the diagram showing how reflection really occurs. So let us look at the sun here. This is the sun as a source of light. So the sun produces the light, and that is called light rays. So they comes out of the sun. And then you do have here light ray as incident ray. Then it strike the ground or the surface. This is called a surface here, or a reflecting surface. So in this case, on the surface here, you find that there's this line here forming a 90-degree angle, or represented by the dot. This line we say is called normal. Remember in Newton's law, we talk about a normal line or a normal force, just like how we draw a normal force. So this is a normal line, not a normal force. This is just a normal, and then it forms a 90-degree to the surface or reflecting surface. Then from there, you find that the incident light ray or incident rays, they strike the surface and then reflected at a certain angle. So this is a reflection. So reflected ray. So if you look very well here on the incident first, you do have the line, straight line, and the arrow. Looking at the reflected, straight line and an arrow. So by the definition of a light rays, they are lines that are perpendicular to the wavefront, right? And then we look on how do we represent them. We say we use straight line and an arrow. Then from there, you do have angle between normal and incident. That is theta I, so, or theta 1. So this one is called an angle of incident. And then this one, theta r, is the angle of reflection. So this side we're having reflection, this side we're having the incident. Now let us look at also what this diagram really tell us about. So they say the figure showing an angle of incidence and reflection are measured with aspect to the normal surface. Now another figure of reflection. Now you do have a line here coming from this side. Remember this line here, because you're having theta I, it's an incident ray. And then this angle here is what is known as an angle of incident. Angle this side, an angle of reflection. And then this side, reflected ray. Then you have your normal. And the surface here, this is a surface plane. Right. So, and then from there, this side we say we're having a plane of incident. So we say that the figure 5.4 shows the plane of incidence in the plane, including incident ray and the normal surface. The reflected rays is also lies in the plane of incident or incidence. Now, let us consider law of reflection. By the definition, a law of reflection, the angle of incident is equal to an angle of reflection. That is theta I and theta r. The incident ray and reflected ray and the normal all lies in the same plane. Now, let's continue. Law of reflection. Let's consider the light coming from the sun, and then you have incident, and then this side reflected ray. This is incident angle, reflected angle. So we need to know or apply a law of reflection. According to the law of reflection, it said that an angle of incident must be equal to the angle of reflection. So which means that this angle here must be equal to this in order to meet the law of reflection. Theta 1 equals to theta 2. So if the light strike the surface and an angle of incident theta 1 to the normal, whereby this is the normal line, if you check very well, this is our normal, and then if is theta 1, we say that a normal, then the angle of reflection is then going to be equal to theta 1. So theta 2 equals to theta 1. It's shown in the diagram. So remember, here we do have a reflecting surface, and then this here forms 90 degree, here 90 degree. Let's finalize. Now the final part, we say that angle of incident must be equal to angle of reflected. This is according to law of reflection. Reflecting surface, reflected ray, and incident ray. All this is produced because of the light source. Right. So remember, this is our normal line, which forms 90 degree to the surface. Now, law of reflection if an angle of incident is 0 degrees. So in this case, the angle of reflecting is 0 degree, as shown in the figure here. So if the incident ray goes straight to the wall and then it bounces back, which means reflected. So you're going to have the scenario like this. So incident ray and reflected ray is going to stick on one point. So which means that you're going to have a line of incident and line of reflected on the same point because of angle. So this is according to the law of reflection. Now, here's the exercise. Please complete this exercise and submit on my WhatsApp or Facebook inbox. So this is the last part. And at the same time, let me just say thank you for watching this video.